Nochmal einen schönen guten Abend. Ich darf Sie alle ganz herzlich begrüßen, liebe Gäste, liebe Studierende. Herzlich willkommen zum ersten Vortrag der Novemberreihe 2022. And a warm welcome to you, Josep Ricart Ulldemolins. I hope you don't mind if I continue in German.
Please.
Also wie gesagt, wir freuen uns sehr, dass wir Sie begrüßen dürfen, wieder in Präsenz. Der Saal ist noch nicht so ganz voll, aber wahrscheinlich, weil Sie noch nicht ganz daran gewöhnt sind, dass es jetzt wieder ganz normale Präsenzveranstaltungen gibt. Sie dürfen auch Ihr Bier mit hier reinnehmen. Sie müssen keine Masken mehr tragen. Sie dürfen natürlich Masken tragen. Und wir freuen uns, dass es heute wieder losgeht. Wir haben 4 tolle Vorträge. Die Novemberreihe muss ich, glaube ich, nicht groß vorstellen. Die gibt es seit 2006. Sie wurde hier eigentlich ins Leben gerufen von Professor Peter Scherret, zusammen mit der Sto-Stiftung, die das Ganze finanziert. Und diese Reihe gibt es inzwischen an zahlreichen anderen Orten. Es gibt sie in Graz, in Venedig, in London, in Wien und in Paris. Aber wir sind der Ursprungsort. Und es geht bei der Novemberreihe darum, internationale Positionen zur zeitgenössischen Architektur vorzustellen und entsprechende Büros einzuladen, die da eine interessante Haltung haben und uns dazu was berichten können. Seit letztem Jahr, vielleicht erinnern Sie sich, haben wir zusätzlich noch ein Motto. Letztes Jahr war das Thema Bauen ohne Beton. Das kam auf Anregung der Studierenden. Dieses Jahr haben wir ein Thema gewählt, was in aller Munde ist, nämlich das Thema Ressourcen. Wir haben das aber nicht gewählt, weil es gerade so Hochkonjunktur hat, sondern wir haben diesen Begriff gewählt, weil er auf verschiedenen Ebenen interpretierbar ist. Also man kann es sehr direkt umsetzen, man kann es aber auch im übertragenen Sinn sehen, was bedeuten Ressourcen heute und was bedeuten Ressourcen für uns, was bedeuten Ressourcen in der Architektur. Ganz interessant, der Kontakt zu Josep wurde hergestellt von einer lieben Kollegin Alba Balmeseada, die hat so einen komischen Nachnamen, kann ich immer nicht richtig aussprechen. Also Alba, die möchte ich hier begrüßen. Leider kann sie nicht da sein. Sie hat den Kontakt hergestellt, das ist eine liebe Kollegin aus Madrid. Und sie hat, wie gesagt, ihn angefragt, er hat zugesagt und dann irgendwann habe ich gefragt, Alba, hast du ihm eigentlich gesagt, dass es das Thema Ressourcen gibt? Und habe ihm gesagt, es geht um das Thema Ressourcen, ob er das weiß. Und er sagt, kein Problem, Ressourcen sind mein zweiter Vorname. Also von daher, und das ist auch, glaube ich, wenn man das Büro kennt, Architektus, da ist das Thema natürlich von zentraler Bedeutung. Aber ich wollte einfach nur noch mal sicher gehen. Um ihn kurz vorzustellen, brauche ich jetzt doch meine Zettel. Wo habe ich die? Oder ich weiß es auswendig. Wo habe ich denn das da hinten? Ach, da unten. Da liegt es. Also, er ist geboren in einem schönen Ort. Den muss ich jetzt doch vorlesen. Cerdanyola del Vallès liegt in Katalonien und hat Ende der 90er Jahre an der ETSAF in Barcelona studiert und hat dort die 3 anderen Kollegen, die zusammen dann im Jahr 2000 das Büro Architektus gegründet haben kennengelernt. Sie haben dort studiert, sie unterrichten dort auch, bis auf Javier, der unterrichtet an der 2. Architekturschule in Barcelona. Sie haben zahlreiche Gastprofessuren, unter anderem in Harvard und im Moment sind Sie auch an der ETH Zürich. Sie haben natürlich zahlreiche Preise auch gewonnen mit Ihren Projekten, weil das Büro gibt es eben schon sehr lange, seit 2000. Und ich möchte nur den letzten nennen, weil der ganz interessant ist. Das war der European Award for Architectural Heritage Intervention. This was a prize you won lately, you remember? And this was for a civic center. Yeah. Und zwar ist es ein Preis, den Sie bekommen haben in der Kategorie Interventionen im gebauten Erbe. Und auch da gibt es natürlich einen interessanten Bezug zum Thema Ressourcen. Und das haben Sie für ein Projekt bekommen. Das ist ein Bürgerzentrum auch in Barcelona. Sie kennen das Büro vielleicht durch eine El-Croquis, die vor 3 Jahren, glaube ich, veröffentlicht wurde. Und da wurde vor allem eben auch ein anderes Bürgerzentrum präsentiert, das Bürgerzentrum, was in einer verfallenen Glasfabrik realisiert wurde. In Ihren Projekten spielt der Kontext, der Umgang mit der Materialität und der Versuch, auf unnötige Technik zu verzichten, eine wesentliche Rolle. Von daher alles wunderbare Anknüpfungspunkte zu unserem heutigen Thema Ressourcen. Bevor ich das Wort an ihn übergebe, möchte ich mich ganz herzlich bedanken, einmal bei der Sto-Stiftung, die das Ganze finanziert. Dann möchte ich mich bedanken beim IRGE, die immer in einem kleinen Ausnahmezustand leben, wenn wir die Novemberreihe vorbereiten, die uns sehr geholfen haben. Gül und Susanne, Spela und Bettina hat heute noch die letzte Anweisung bezüglich IT gegeben. Und auf Nina und Falk, die die Veranstaltung filmen werden. Und da möchte ich noch darauf hinweisen, wir werden auch Aufnahmen vom Publikum machen. Allerdings werden wir nie nah heranzoomen. Aber trotzdem, wenn jemand sagt, ich möchte das nicht, dann jetzt die Hand heben, dann schwenken wir immer woanders hin. Also keiner. Dann, wie gesagt, es gibt Fortbildungspunkte für die Architekten, die in der Kammer eingetragen sind, auch für die AIPler. Draußen gibt es eine Liste, wo Sie sich eintragen können, und es gibt eine Teilnahmebestätigung, wo Sie am Schluss der Veranstaltung einen Stempel kriegen, und voraussichtlich kriegen Sie 1,5 Punkte für jeden Vortrag. Dann noch ein letztes, die Getränke. Da bitten wir um kontaktloses Bezahlen und um eine Spende. Ein Bier wäre ganz schön, wenn Sie da einen Euro in die Kasse werfen, und für die Brezel 50 Cent. And now the floor, I may give you the floor. Thank you very much. It was too long.
No, it's been perfect.
Okay.
Thank you, Kaira.
Kura.
Kura. I hope it's been a kind presentation, because I get nothing, but I'm sure it's been kind. Thank you very much. Well, hello, I'm Josep. I'm here on behalf of my partners and me, Xavi, Roger, and David. Whatever you don't like it, it's because of them. Whatever you like it, it's because of me, so remember that at the end. And as I think most of the architects, when you invite an architect, doesn't matter the title, doesn't matter the general topic, we always talk about what we are a specialist, which is about how we project architecture, nothing else. So the title is just a very short summary about that we, in general, we believe that to project architecture is basically to project our own experience under certain conditions. And to project that in, let's say, a level of environmental responsibility means also that those experiences have to be as long, as intense, and as based in natural conditions as possible. We also like to use as a general definition of architecture what more or less Lewis Mumford used to say, also Paul Oliver, which is that architecture is the shelter of human being in nature. Not against nature, but in nature. That means that we love to imagine that idea as the architecture, as that kind of tools that manage the natural conditions, the physical phenomena, in order to provide protection, to provide shelter to human beings, to people in general. And this is not only that, this is something that not only happens in vernacular architecture or in traditional construction. There's a lot of examples on the modern architecture, contemporary architecture, based on that idea that we should manage the natural conditions in order to provide comfort. There's a lot of nice examples about that, but in general, modern architecture, contemporary architecture, as the rest of society, in the moment that the fossil fuel era began, we have forgotten all that idea that we can provide comfort by using natural conditions. We've forgotten that, and we have that fake idea about infinite availability of resources, that idea of infinite amount of energy, something that is clear that is a fake concept. But as the rest of the society, architecture has accepted for 150 years that this is like this, so we have begun to forget all that story about our relation with the natural conditions, and we have begun to be a way of nature, to have just a visual relation with nature, and at the end we've been living, we've been designing real fish bowls. We are just in that kind of artificial atmospheres in general, and this is something that we are also part of that system, but we try to go a little bit farther than this. Also, we have a social architecture. Of course, it's architects are part of society, of course, and as a part of society, we are in that fake concept of the infinite amount of energy, and also in that predominance of visual perception as the only way to, at least to communicate, at least to imagine architecture. We've been dealing with just visual architecture for years, and this is easy to be understood. Visual perception is the fastest perceptive system, is the more efficient perceptive system, but of course it's not the only perceptive system. We perceive using all our perceptive systems. We have an haptic perception of reality, but because of communication, use visual as the main way to communicate, architecture has used visual also as the main way to design. Designing that kind of metaphysical architectures that are only imagined to be seen, to be viewed, and that of course that needs to be plugged into an engine or whatever in order to provide comfort. Doing something that for us is a big pity. That means that we have forgotten that in the responsibility of architectural design is also the design of the real comfort, not only about the visual perception of the space. So we've done that. We've forgotten that with architectural tools it's possible to design also tactile comfort and not only visual experience. And this is something that in our case, I think that we were very lucky when 15, 17 years ago we began to be concerned, to be interested about sustainability, environmental responsibilities and whatever. We were lucky in both, in two conditions. In one hand, our clients were not rich enough to assume technological, efficient, sustainable solutions for our projects. On the other hand, our fees were so low that it was not possible to get simulations, CFD simulations, thermodynamical simulations. That's why I think that we were lucky, because thanks to that conditions, that economical conditions at the beginning of the financial crisis at 2007, our only way to approach architecture with that level of environmental responsibility was by using pure and simple architectural elements, architectural tools. First of all, how we use the buildings is the first sustainable strategy. It's something as simple as to imagine that not all the parts of the buildings have to have the same level of comfort, the same temperature, the same ventilation, whatever. Second, a simple decision in terms of what kind of material and products we can use by that moment, not only biospherical material and products, also geographical available products very close to the site of our buildings and so on. Third, the use of passive strategies based on architectural decisions as geometry and material. Just by defining geometry and using specific materials with high amount of inertia and so on, we can get comfort based on architectural design. And if active systems are necessary, then trying always to introduce those active systems in the elementary parts of architecture as in the structure or similar. And this is where we are now, more or less. This is a beautiful painting from a Catalan painter called Ramon Casas. The title of the painting is a manifesto itself. That paint is called An Indoor-Outdoor, the inside-outside. And for us explains quite well what we define as reciprocal architecture or the architecture of interdependence. That means that we always try to put in contact, to put in touch the human being with the natural conditions and with the physical phenomena. Something that is so big, that is so bigger than the human scale, that is not only to talk about comfort, it's also to talk about an emotional experience. And architecture is that soft, quite invisible part of the painting that is just producing conditions in order to put in contact the human experience with those natural conditions. Not only to give shadow, but also to give inertia, to use a geometry to produce cross-ventilation, but at the same time to protect from the wind, also the green and whatever. And for us, this luxury experience that show the face of that guy having an app is what we are trying to project the experience of that people based on the reciprocal relation with something that is far bigger than people. Now, well, I've tried to explain that basic position or approach of the office. From this point, I will talk you about 10 projects, what is too much. So, but the important part, it's been already explained. So, don't worry if you lose your attention at any moment. That idea to be in touch, to be that relation between human being and something that is bigger. First of all, that idea that what is bigger is the natural conditions and the physical phenomena. On that kind of spaces where convection is really intense, where the sun gain, what is at the end what we call atriums or atriums basically. In our architecture, there's some spaces like that are putting in contact the human experience with the physical phenomena of the inertia and the cross-ventilation, which is our basic thermodynamical strategy, which is absolutely logic in Barcelona. Of course, it's not the kind of a strategy that you can assume here in Stuttgart. But in fact, as you will see, we are a really local architects. Our practice, it's been not far away from the office than more or less half an hour by car. Well, it's not true for all the projects, but maybe 90% of the projects are like that. So in that local conditions, our thermodynamical strategies are based absolutely in the idea of as bigger is the amount of inertia in our spaces, the more stable is the temperature, and that needs, on the other hand, to cross that strategy with very strong and very intense cross-ventilation in order to take off of the inertia at night the amount of heat that the inertia has kept during the day. So this courtyard is in a house close to the office, half an hour, let's say. From that former facade, we developed that atrium that is covered in winter and open in summer. In winter works as a greenhouse effect, getting the sun gain. In summer is these big walls, very wide walls, give fresh and cool atmosphere to that space that is not specialized, is not highly defined by its function, but it's really special. It's a very special experience because the space is special in order because of the behavior, because of the material, because of the high. Also, it's explaining a little bit the structural behavior, but this is not so important. Also, the porch is a space for interdependence, and a space where human experience is put in contact with what is happening outside of the house, not only because of the cross-ventilation, also in that sense of also a visual relation with what happens outside. So porches in plural is also that kind of a space, of very special space that we've used in our projects that are again in that strategy of make an intense experience based on the natural conditions comfort. So in that sense, we believe so much in that kind of experiences that it's not just a porch. In fact, in that case, it's the real sitting room of that house, which is a house for a real rich guy. But he assumed that, that the best place to be in winter and summertime was the porch. So, and he's a guy that he doesn't want a TV and whatever, so he was the perfect client. And so this porch works as a porch in summer and works as a gallery in winter, but it's always the sitting room of the house. In this case, the porch is the whole house. The porch in that case, which is a completely different budget house, really low budget example, but the plot was so narrow, so ugly, so bad shape, that instead of assuming that the garden that will rest after the geometry of the house will be just that kind of basic surrounding, we decided to make the house as small as possible, just assuming the very basic parts of the house as bathrooms and bedrooms, and the rest was that porch that increased the perception of the garden. So it's a very, very small house surrounded by a garden, and the porch is that part that assumes the daily activities surrounding that part of the block where the bathrooms and the bedrooms keeps inside. Completely open in summer and like this, and closed in winter. In order to make the budget as lower as possible, we decided to move the sheet, the metal sheet, instead of moving the glass, which is also always more expensive. In this case, the whole building is a place for interdependence. The whole building is providing natural conditions, like natural different environments for the people who's working inside. This is the whole building works as a greenhouse in winter and as a pure porch in summer. This is a research building. It's as easy as a building into a greenhouse. It's a real greenhouse built by greenhouse builders, and so it's a very simple idea, but it works quite well. In summer it's completely open. In winter it's closed and works based on the sun gains, like this. Putting in relation the users of the building with the natural conditions from outside. Let me explain a little bit better, or at least a complete project, not just a frame of the project. This is a house that we finished it last year at the beginning of 2022, but it's a small house, but for me it's a good example about that kind of special spaces, but not specialized spaces. This is a concept from Jacques Ondelat, not from me. That idea that we have to define spaces highly defined by how specials are, but because the volume, but because the mass, but because the shape, but not because of the function. Because the more strong is the function that defines the space, less easy to be free to do whatever you want to do in that kind of spaces. So we agree with that idea. So our spaces never works perfect, never. So there's always problems, there's always mistakes, there's something, the plugs are always too far away from your bed and whatever. But in terms of colonization, in terms of freedom of use, are always open, are always fun, are always a nice experience. In this house, a small plot, very typical example in our towns, in our towns, birthplaces, is that kind of attached houses, that kind of urban fabric. But this facade that you've seen are facing west. West in Spain is the worst orientation possible. The northern you go, the concept change. But in Spain it's terrible because west, you don't have sun in winter, and the sun that you have in summer is too hot because it's the last moment of the day, so all the air is really hot. So if you add the hot air with the sun coming into the house, it's terrible. So this plot is not only facing west, but you have a neighbor on the right side of the slide, which is completely hiding any possibility of sun gain, because in the south orientation of the plot, you have that ugly building 12 meters high. So it was a problem in order to get some gains from the sun and to close the house to the west. That's why we decided to do something really special, really strange for it's a house for one single man family, because he's divorced, he has a girlfriend, he has a daughter, but most of the days he lives alone, so it's a small house. But just on that thermodynamical conception, and also with that, with always trying to find out that idea of very special and intense experience, we decided to propose to the guy that strange space as high as the neighbor in order to get sun gains from the rooftop, okay, from the skylight. So that means that you're producing a very special space, 12 meters high, non-programmed space, non-functionalist space, just the space where whatever could happen, absolutely close to the west, but absolutely open to the sky in order to get that sun gains in winter. Of course that you need the house for the single one-man family. So as he don't want to have that sensation to be alone at home when his daughter is not there or the girlfriend is not there, we propose him to put one bedroom over the other, to don't have that sensation when he's alone that the bedroom at the other side of the stairs is empty. So his bedroom is the first one, the daughter bedroom is the second, and for guests, the third bedroom. So it's a very vertical house, but he can be living just with the street level floor and with the first floor. Then, of course, that thermodynamics shows up. That very vertical space is not only about the experience of vertical, but is also about a natural engine to promote, to help the natural ventilation, but not opening to the west, just by the sun, just by the chimney effect of that vertical space that is helping convection and is producing and emphasizing the ventilation of the house. In that kind of, so this is a very special space that is at the very entry of the house, and if you look to the skylight, it's like this. It's a really intense experience, it's really beautiful, and he's absolutely, you have to imagine, he's I don't know the name in English, apothec, he's a chemistry, well, he's a very traditional guy. He's a friend of me, but he's really traditional. He always wears like ties and very elegant. So, but he was confident enough in our proposal. He was unable to imagine that space. It's impossible to imagine this just by models or drawings or whatever. But the reality is that he's absolutely in love, not only him, but the family, the friends, and whatever, to make parties here, to have that experience of the skylight and whatever. The rest of the house is absolutely the opposite. It's absolutely cozy, it's absolutely small, it's absolutely comfortable because it's the bedrooms, and as this space is based on inertia and also in a heating pavement, the rest of the house is based in pure insulation. It's absolutely protected by a double layer of facade and gallery. So all the bedrooms are double check protected from the outside, and all this part is made with CLT timber panels. These CLT panels came from Spain. At the beginning of our office, when we began to work with CLT, we began with Austrian and German like Binder or KLH. Now we are working with factories from the north of Spain that they have begun to produce that kind of CLT timber panels on pine, not on spruce, and we prefer that. And well, the rest is not important. The strategy is like this, and the house, it's quite beautiful and whatever. The other thing that is interesting of this house is that it's really small, it's very simple, as you've seen, and it's very Euclidean, it's very orthogonal, it's so simple, the huge space, the bedrooms. What for me is a big discovery is that in general that kind of attached typologies are always based in that the staircase are in the middle of the house, working in general in the traditional and vernacular attached houses as a natural chimney for the ventilation. But this kind of a staircase means that you lose the length, of the house. So we decided here to put the stairs like surrounding the bedrooms, changing its position in every floor. So in order to don't have the sensation that there's a specific space for the stairs. So the stairs begin like that, then turn on the left, and then turn again. So the staircase is changing its position every time. We use the understairs to put the WC in every floor because the bathroom is always, the water area is always in that gallery. So all the bedrooms are related to the outside through the bath area, which in general, in terms of conventions in Spain, is like pure evil. I mean, but in that case, again, that elegant, traditional, conventional man, he feels absolutely comfortable with that idea that his window is a bathroom. So the stairs are like this, are surrounds with that relations with the big space surrounding the bedrooms. At the end, the cozy bedroom with the gallery at the end, where is the bathroom. Well, that idea that I was explaining at the beginning, our challenge, that is to put people experience in contact, in touch, in that relation of interdependence with something that is bigger. This is not only about natural conditions and about physical phenomena. It's also to put in touch, to make people aware about the time. Time is something really big. I'm not talking about time in terms of poetics. I'm talking about time as a real vector that is part of design. And time basically has two different aspects in our approach. In one side, time as memory, and the other side, time as behavior. The behaviors of the buildings are something that only happens if time exists. So, because buildings are not sculptures, buildings are something that have a behavior, that have a performance, and this is also a vector of time that can be shown to the human experience. I would explain that with that beautiful picture in a very old quarry. But when we have got lots of, as I think that Kuras explained, we've got a lot of experience with heritage. You told about that. But our first approach to heritage, to pre-existing buildings, with a high level of cultural heritage or whatever, never is about culture. It's always, first of all, that we check in the heritage is the attributes of that heritage to keep working, to keep performing into the new building that's going to happen. So I think that that's the best homage, well, the best that you can do with a beautiful old building, heritage building, is to give a new sense to that building, to put the building in work, to stress again the building, making the building work in terms of a structure, inertia, comfort, and whatever. Then, of course, there's a cultural dimension that we have to manage too, but this is a second step. And the first attribute of pre-existing material, of pre-existing architecture, the first attribute is the geometrical attribute. So is that building still able to assume new programs, new users, new groups of people? In this case, what used to be a workers' association in the end 20s of the last century has to become into a new social, cultural center and whatever. Our first approach was not about the sense of culture, because only the facade was protected by law. It was to check if the geometry of the structure, what is really fixed in a building, was still able to assume new programs, new elements. So what we decided is that part of the building was still really able, really capable to assume new programs, but part of the building gonna be far more useful if we demolish that in order to produce a new space that gives new and necessary attributes to the former spaces that remains. So basically, we provide that section, demolishing part, the right part of the building, what was as old, as interesting, as culturally interesting as the rest of the building, but in terms of geometrical availability was not so useful as the white part of the structure. So the former spaces remains maybe with new attributes for the new users, but in terms of geometry, this was perfect for a rehearsal room or whatever, and the new space gives new attributes to the whole building by getting sun gains, natural ventilation, also circulations, and providing that sense of the street coming into the building. Time is not only about memory. The previous was a clear example of to work with memory, to work with heritage, and so on. But time is also about behavior, as I've said before, because as I've been trying to explain, well, we work a lot with thermodynamics concepts, and this is about time happening, one thing after the other, one thing after the other. This is a very clear example about that approach. This is a building that is basically an adult school for elderly people, and also people who want to learn Catalan and something like that. And so it's an equipment, it's a facility, it's a public building, and it's very simple to be understood. We want to make it work by its nature, by natural behavior, based on inertia and natural ventilation, and so on and so on. The big challenge here was that we're not only getting comfort with that very passive strategy, but we are moving all the air for renovation, all the air for healthy, based also in a natural engine, which is the sun chimney that you can see at the top of the section. So this building moves in summertime 15,000 volume meters of air per hour, thanks to a natural engine. So it's not only that the building has no fans to produce HV, artificial air-conditioned systems, but it has no fans to move just the natural ventilation for the renovation of the air. The air comes from outside, moves in a large path through the basement in order to get more stable temperature. Then from the basement come into the courtyards, and from the courtyards, because of the because of the natural engine that push up the air just with that natural phenomenon, that physical phenomena that is a sun chimney, which is a greenhouse effect, is a Venturi effect at the top, which is also a physical phenomena, and it's also a chimney effect. That means that the difference of pressure of the air helps to move the air. So thanks to that natural engine, the whole air can cross the bedroom, either classrooms, and goes up. The beautiful is that, of course, that in order to put all that amount of inertia into the building, we use that very traditional, old-fashioned structural system that means to work with structural walls, bearing walls. All our architecture in general is based on bearing walls made with bricks or whatever, even with CLT timber panels. But we are always working with that idea of that thanks to the structure gives as much as attributes to the space as possible. And when you're working with bearing walls, with the structural walls, you're getting not only the support element of the building, you're also getting that thermodynamical element that helps to produce comfort because of the inertia of the walls. But in this case, it's not only because of the inertia what is interesting in the structure. It's also because of the bearing walls are not stabilized with the crossing walls, are stabilized with a very short elements also made with bricks that produce the channel, that produce the camera, that leads the air from the classroom to the sun chimney. So the whole building, the whole structure, not the whole building, just the structure is doing quite everything. It's not only supporting people activity, it's giving conditions, it's giving attributes to the air, and is also leading the air in the path from the very outside to the end of the process. So this is the south facade with that courtyard. So the air comes from the basement, and if the air outside is in good conditions, also can come from here, and then through the windows come into the classrooms. This is the other courtyard, and the sun chimney push up the air in order to take this off. To be in touch with that group of elements that are bigger than human being, like natural conditions, time, is also to talk about social, economical, physical resources, to be in touch with what is happening around us in our societies, in our villages, in whatever. So to be in touch with traditional constructive process, to be in touch with geographical resources that are available, to be in touch with all of that. But not only with that kind of obvious image about a worker, handing and whatever. Is also a condition of that, the idea of mass production, prefabrication. This is also about resources. This is also to talk about products. This is also to talk about preexistence. The products already exist. The designs, the profiles, the prefabricated systems already exist before we began a design process. So it's also a preexistence. It's something that we have to be aware, we have to be concerned. This is a dealing with it in the school that we teach, in the school that we learned. It's 15 minutes from the office again. And so our students are living here. The 4 of us, we are alive. That's a good news. That means that the building more or less works all right. And this was a competition we won with friends of us, Datae. And I present that to talk about resources, but it's a prefabricated system. So it doesn't look like the beautiful picture of the worker placing stones and whatever. But also prefabricated system is a resource. It's something that exists. It's something that we have to deal with. We can take the best of it and whatever. But it's also an example about a different idea of a symbiotic strategy talking about resources. This building is just in front of the architectural school that I've told. And won the competition because our building was the cheapest one, was the lowest one, was the larger number of bedrooms one. It was the and we won because in the jury, the constructor was in the jury, so he was absolutely happy with our proposal because it was the lowest budget proposal. But this lowest budget was based on, I think, real efficient strategies. The basis of the competition asked for studios, asked for gyms, asked for coffee, cafeteria, a bar, whatever. But it was like a silly asking or a silly basis when we were really close to a building that has studios, that has cafeteria, that has everything. So our first decision was to take advantage of the resource in terms of programmation of the former school. So in terms of programmation, we transformed the former school into a resource for the project. In terms of water, we were with that idea to have a lot of garden, a lot of green in that new dwelling for the students. So in terms of water, we proposed to take advantage from the huge roof of the former school. And also in terms of energy, we developed that symbiotic idea based on a very silly and simple question. During the day, the students are at the school. During the night, the students are at the residence. So it's absolutely obvious that we can use the same heating system of the school in order to provide comfort and heat into the new dwelling. It was the hardest part, the most obvious, because as the owners of the buildings were different, it was very hard, very tough to put them, to make them agree into that very obvious decision. At the end, it works. So this was the first, and it was in these drawings are from the competition to explain that very basic idea about how to take advantage about the existing resources in the plot, understanding the existing building as a complete resource. The other element of the competition is that the competition asks us to work with that prefabricated element. This is an element with copyright that exists in Barcelona. It has a name, it comes from a factory, so it was part of the competition. We have to deal with that. It was a three-dimensional prefabricated element in concrete that works like in a factory. It's like a car construction process. Every day the element moves one step in order to introduce the kitchen, the facades, and whatever. And then you move to the plot and you place like that. We did that just 2 floors building in order to avoid the elevator. New save in terms of budget. So the promoter was happy again. So what we did with that already existing product, that means the compact habit element, 3-dimensional prefabricated concrete element, whatever. We work with their engineers in order to show the element as it is. The original design of that prefabricated house, let's say, it was defined to don't be shown because the engineers were not, in their opinion, it was too ugly. So they defined a concrete element that always need to be coated, to be protected with plaster boards. Because if not, the acoustic insulation doesn't work. If not, the fire white protection doesn't work, and so on and so on. For us, it was absolutely silly because the beautiful of the product was there, was clear to us. So we were dealing with, when we won the competition, we were dealing with the engineers in order to put an extra bar here to make more efficient the concrete, to change a little bit the dosification of the concrete in order to have a legal constructive element that can be checked with all the norms, but can be shown as this, with that very basic idea again, that if we have architectural students, I mean, we don't need nothing else than to give them just a pure support, a pure structural geometrical support to be colonized, to be developed by its own. So we basically proposed a geometrical conditions where 2 bedrooms can be achieved, 1 bedroom, big sitting, whatever, and they decide how they really develop the space just with furniture. The same idea was in the garden, so the garden was just a pure empty space, designed in terms of conditions to make it more green, thanks to the water of the roof of the school. The same with the facade, and so on. So this is about resources, but not in general what is beautiful to talk, what is, at least when someone see our architecture, which is that idea of local resources, traditional construction, and whatever. We did that school, very based in a very prefabricated system, and we deal in the same. I mean, our approach was basically the same. So to take as maximum advantage of the nature of the elements that we work with. So is this element based on concrete? So then we need the inertia again. So we have to take off all the plaster boards because the inertia will help to the comfort again. This is a different case. This is a house in a beautiful, beautiful old village in the Catalan coast called Ullastret. This is a beautiful, narrow streets with that kind of old houses, 3th-century-old houses and castles, and is a really nice place to go. And we had that commission, which was for a weekend house in a beautiful plot with that incredible wall that surrounds, because it was an agricultural, it was a orchard, it was a vegetable plot, okay? So it was surrounded by this beautiful wall, 3 meters high in some places, and the council norms in that place ask us to make that kind of what we call crocanti facade, that is like that kind of facades simulating, that is based on stone, and that kind of to be in mood with the surroundings. So it was easy to us because the answer was so clear. As we have that beautiful wall, the house, it's going to be something that will use the wall in a structural sense, as inertia element, and also as a facade, because it's the council norms ask for that. So we developed that very simple house attached to the former wall, beautiful again, and whatever. The problem was that when we went to the council and asked for permission, the urban plan planned that the street was too much narrow for the trucks. So the wall has to be demolished, okay, and has to be removed and has to be replaced in a new position. So after a first big crisis, crying and whatever, and we're always like that, very excited, crying, excited, crying. And so we decided that maybe in terms of geometry, the attributes of the heritage gonna move on, because the geometry not gonna exist, doesn't exist for, it will disappear. But in terms of inertia, in terms of structural attributes, the stones still remains with those attributes. So we decided to rebuild the wall 1.5 meters beside. With that idea, that is not to build again a stone wall, but to build again like a mix between rammed earth wall and cyclopic concrete structure. Okay, so we use the former walls in order to do that wall based on the former stones with lime cement, place it in a rammed earth strategy, and also mixing this with insulated air glass balls in order to put air into the wall. That means that with a 50-60 centimeters wide wall, which is absolutely, it's really wide, it's something that not always can be placed in different plots, but here was possible because we were plenty of space. It gives us the insulation enough to develop a one-wall house. This is a non-layered wall house is a just one layer wall house, okay? So, and at the end of the process, so this is not all the walls have the same density of stones because it depends on the structural behavior and also on the static behavior because our, well, the typology, it's very simple, it's very obvious. Remember that is a weekend house, so, and we have a good climate, let's accept that. So you have to go through the garden if you don't want to cross through the child's bedroom, if you want to go to your own bedroom or to the guest bedroom. So this is the rammed earth process with the former stones placed with the lime cement. And this is the final part where when the casting system is taking off, we just pierced the surface in order to show again the former stones that at the beginning of the story was 1.5 meters in front of that position. So it's a little bit again the same. I mean, our approach to heritage is not about culture, it's about attributes. So if the wall is not again in the same place, but still remains certain attributes of the wall in terms of structure, in terms of inertia, we take advantage of that. So this is, as you can see, this is the original position of the wall, and this is the new one. On the other side, it's not really important, it's quite obvious, it's like a porch facing south, getting advantage of the sun again. Completely open, but as they just come here on weekends, there's no heating system in this house, but they come here just on weekends, so during the winter, and we don't have tropical winters by the moment, maybe let's hear, on winter, during the week, what we really have is a lot of days with sun, as you know, so doesn't matter the temperature, but just because of the sun and the greenhouse effect, when they arrived on Friday, even in winter time, the house is warm enough. When they move on Sunday, they have cold again, so they need to wait for 5 days of sun after come back. So our houses, this is again a rich client because we don't have to lie about that. I mean, this is really economical material products, as you've seen, absolutely tough elements. But what is expensive in construction is the hours of people working. It's not material. So, I mean, we lie to our clients because we say, no, don't worry, this is a very economical, and it's true, it's very economical. But our approach to architecture is so craft work, it's so a craft work, but at the end becomes expensive, but because of the number of hours of, but this nice idea of that big wall with everything included, with that very intense experience in touch with that lime color and whatever, needs that kind of very slow craft work. Well, and just, with my, okay, it's okay? Well, last project, so last experience. I know I'm repeating myself, but it's the only thing that we are really interested about, which is about that idea of natural comfort, how to get real comfort with real materials based in something that never gets broken, which is the natural behavior of the elements, which is the natural behavior based on thermodynamics, which is the structure behavior based on the geometry and material that you've used. So this is an example about that, but not for people, but for wine. Okay, so this is a cellar that we've done in also again a beautiful village in the south of Catalonia. This is an area, I suppose that in German it's not well known, but this is an area called El Priorat, which is, they have really good wines from the last 20, 30 years, before of that it was not so good. But this area is very traditional, that the sellers, that the business are really small business, so are really family business, really small production, short productions. Not all of them, but the common of the sellers are really small. And the tradition is that the cellars used to be in the basement of the houses, not in the middle of the landscape, not in the middle of the vineyards, but in the middle of the village where people live. So in the same sense, the owner of that vineyards decided to promote a new cellar to produce more bottles, 75,000 bottles, which is really small production. So to do that, he bought plots, attached plots in the middle of the village, just close to the beautiful church of that place. The norms were so simple. You cannot complete the plot. You have to have some distances of the neighbors, and we decided to have the same distance in the whole plot in order to have a very regular, very orthodox, very orthogonal geometry for the production, for the productive part of the cellar, and to have the rest of the geometry in order to put there the logistics, the coming of the grapes, the go out of the bottles, also the social part of a cellar. You know that nowadays, every day is more important the social aspect of a cellar, the commercial part, to have a small bar, whatever. So we did that, but we asked the council also for permission to cover a little bit that part just with roofs to protect a little bit from the rain, and they accept that solution. So we have the very elementary geometry, very tall for something that I will explain you later, which is again about convection again and again, and the rest very open space for that logistics and social activities of the cellar. The basement is what's the name for that? Well, basement with a typical wood bats. It's not bat, but whatever. And then the batting rooms where the vinification happens, and in parallel all that logistics and social path. Upper levels are just for auxiliary programs like an office, a tasting room. So this is the big volume, just close to the church. This was beautiful because it's not very typical, at least not in my part of Catalonia, but in this village, one of these plots used to be un fronton, that kind of game, very typical in Basque Country, that they play with a ball against a wall. Okay, so the first wall was already there. So this wall, a little bit, part of this wall was already there because was this playing game, this playing card. But here you have the vinification building and the space in between. Okay, so the funny part here is that we always work with bricks. We love bricks. Well, we not always work with bricks, but we work a lot with bricks, with red bricks and special bricks, whatever. In this village, bricks are forbidden. Because for them it looks too much like a cheap farmhouse. Okay, for pigs and that kind of. So for them it's like a prejudice that they have, that bricks are for pigs and not for people. So the bricks are forbidden for facade, but we lie a little bit to the measure of the city with nice drawings showing quite yellow bricks that could a little bit mix with the rest of the village. But when he saw the final result, he was absolutely mad of us. He wants to kill us. So he asked for sure that the bricks has to disappear. But the building was beautiful, was already finished, and we were again crying and again excited because we have a sentence in Spanish. This is something like, there's always good after the bad, something like that. Or when you have something bad, then the good comes, something. It's no hay mal que por bien no venga, okay? So, and the history of the office is always like this. Because of that terrible moment of crisis, the mayor wanted to demolish the building because of the color of the facade. We developed all our buildings are based in a real technical research. All of them after the building, behind the building, the beginning of the process is always based in a research about materials, about products, about behavior, all mixed, okay? In this case, there's a lot of research, but there was a new added research based in how we can hide the brick but show the texture. But not with painting, because painting was not allowed again. So we developed that what is called jabelga, which is like a traditional mortar, very, very thin, that you applied like a painting, but has grain, lime grain, like a mortar. So it's thin enough to show the texture, has that beautiful natural color of the lime, so it's not artificial pigment, mixed very well with the rest of the facades of the town because of the lime mortar of the walls. And it was, again, an exciting research in order to make more intense the experience, not only of the visitors, also of the architects, what is also important. So this is from outside. And then this is that in-between space for the social. This is the space where the grapes come in. And you can see the batting room. And there's going to be a small bar. Now is a small bar to have a drink and whatever. This is the roofs that also make that the rain, when comes, make it slower because there are green roofs. And the final element, which is a little bit to make a small concert or presentation or so on. Well, just to really end, the final research, which is, but is also about that thermodynamical general idea. Our challenge accorded with the client was that the building by itself, just for natural behavior, just based on geometry and material decisions, will be always between 17, 18 and 24 degrees. The low temperature is not important in wine process, okay? Could be 14, could be 13. But to don't be up to 24 is really important, and it's really difficult because Priorat, Gratallops, in the south of Catalonia, is not as temperate as Barcelona or as Tarragona in the coast. It's less humid, it's less wet, but the difference of temperature between summer and winter is larger than when you're close to the sea. So to be under 24 in summertime, just thanks to the building, was the big challenge of the building. So here, and it's been the building where we've been where we've gone far away if you compare with the rest, we've placed an incredible amount of inertia. So the walls are like this. The walls have like 1.20 meters wide, okay? So are huge walls, structural bearing walls, okay? But it's not the thermodynamical relation to get an advantage from the inertia is not only based on the mass or on the width of the walls. It's also based in the surface of interchange, because if the inertia is that big invention that keeps the excess of hot on summer and give you back on winter if you are close to the sea, or give you back at night if you are in just a simple building, you also need the maximum surface possible, because it's in the surface where that interchange is happening. So that's why we've done these structural walls divided by cells in order to not only have inertia, but also to have as maximum as possible of interchange surface, okay? So this is the invention, but the natural behavior is very simple. When the outside conditions are positives, are good, the windows are open, and you have a natural convection because of the high that moves the air, and that's all. On summertime, the natural conditions are only good at night. So at night, in this place, we are basically under 20 degrees, 20, 21, 19, 18. So that's the moment that you really can open the windows, okay? And the convection happens and so on. But during the day, it's so hot that you have to close completely the building and get the advantage of that inertia that you've been refreshing during the night, okay? So it's like that, so that intense and a little bit bizarre aspect of a building wall, but also gives that, because it's not only the walls that are like that, also the roof structure is the same. You will see. So here you can see the constructive process, standing up the walls in front of the church. Okay. There's also an insulation layer on the last layer in front of the facade. Okay, so here you can see how the walls are open to the space to produce that the beginning of the convection. Okay, but also the roof have the same system with beams, that the bricks over the beams are also pierced in order to also to let the air move through the structure. Okay, so here you can see how the cells goes up and how the roof system is also open to produce also the movement of the air here in this position, because here there's a lot of inertia too, so we have to take advantage. So we want to move the air and to touch as maximum as possible all the surfaces of the structure, because it's where we can keep the hot or keep the fresh. That's the, whatever. This is a beautiful space. It's high because of the convection, nothing else, and whatever. And we can say that it's not only under 24, it's under 21. So it's really, remains really stable during the summertime. It's really, really stable. The final and ending and bizarre invention is that all that is only the sun chimneys, all this is only possible. I haven't talked bad about engineers. I always talk about engineers in my lectures, but at the end I always say the same. I mean, to do that, it's only possible with engineers. I mean, we have the thermodynamical concepts, we have a basic concepts in terms of thermodynamics, but we need simulations to check that all this will more or less happen, okay? At the beginning of our career, it was not possible, so we were very tough, very basic, biospherical material, cross-ventilation, inertia, and whatever. But to do something like that, you need friendly engineers, which is not common in Spain, to check that this is possible. Are the kind of engineers that understand that comfort needs engineering, but doesn't need engines, which is, for an engineer, is quite surprising. But it's like this, because we need their wisdom, we need their calculation, we need their simulations, but we not necessarily need engines, because engines are not about architecture, and we are architects, so this is so simple. Well, the invention is that in front of the sky, which is the infinite amount of inertia, is the direction that we lose more heat. So that's why we have hair, that's why bald people use hats, that's why people in north of Africa sleeps in the rooftops, because it's in front of the sky that you lose more heat, okay? So what we developed in this building is that that pool with a layer of water, that during the night, the water is in that position, losing heat to the sky, okay? During the day, the water goes down to this camera, absolutely cold, absolutely fresh, in order that just for conduction, because it's in touch with the structure, to make the structure cooler, to make it colder, okay? That makes a magic thermodynamical moment that during the summertime, the air goes up, but then goes down, because it's fresh enough to move the opposite movement, which is quite intense, really interesting. That's why we are getting less than 24 degrees, okay? Because it's not only about the inertia, it's also about the freshness of the sky. And for me, this is it's not for people, it's for wine, but this is the final example I want to show you about that idea of interdependency, about to put in relation the human experience or the grape's experience with something that is far bigger than us. I mean, I'm not against about the human scale, but what I have to say is that when you feel in touch with something that is so huge, that is so large, that is so bigger, that is so infinite, then the experience becomes a real emotional experience. And we are not just talking about survival, about shelter, about habitability. We are talking about real luxury, which is the luxury about that kind of feelings, about that kind of really strong and tough experience. So with that, I hope beautiful final concept and that final pool picture, I end, and thank you very much.